Welcome back to Python Desktop Application Development course. My name is Bo Milanovic. In this module, we will look at some of the basics of Qt and how it integrates with Python. In our last video in the previous module, I promised that we'll dig straight into the code, and I intend on keeping that promise. In this video, I'm going to talk about setting up a basic structure of our code, a code that must be present in every desktop application, at least when we're writing it in Python and Qt. I've started up PyCharm here, our IDE for the course, and with it, when you first started, you're greeted with the screen that looks like this. One of the first things you should do is make sure that you have the correct interpreter selected in the PyCharm settings. To do that, you just hit Configure here, hit Settings, and find the Project Interpreter setting. Make sure that you have 3.4.1 selected. PyCharm should automatically recognize all the interpreters you have installed on your computer. For example, in my case, that's 2.7.8 and 3.4.1. If for some reason it does not detect one, you can just simply add one by clicking the setting button and taking you through kind of a add an interpreter wizard. Once you're done with that, you can hit OK, and don't worry about the fact that PyQt does not appear here. This is just for packages that were installed using the pip. Now I'm going to create a new project, and I'm going to name it Pluralsight. Also make sure that you have the correct interpreter selected here. Hit OK, and we are greeted with a screen that looks like this. In our new project, let's create a Python file. To do that, I'm going to right-click this folder here and select the Python file. I'm going to name this file structure. Now PyCharm has this setting where it automatically inserts the name of the author, so let's get rid of that quickly. And another thing that I'm going to do is, this is taking up too much space, so if I just double click this file name, it's going to get rid of that for me, temporarily at least. Now in order for us to have a basic or skeletal structure of our code, we need to do two simple things. First, we need to import our PyQt libraries that we've installed earlier, and we also need to make some specific method calls that will enable our PyQt applications to run. Additionally, we'll have to import the Python's sys library, and that comes with this Python standard library, and I'll explain why later. And that's it. I promise you'll be easy, didn't I? So let's do this thing. As mentioned, first we need to import the PyQt modules we need. So if I just do from pyqt4.qtcore import asterisk, and also from pyqt4.qtgui also import asterisk, finally import sys. And as far as that's concerned, we're done. We have imported all the dependencies we need in order for our application, or our Qt application, to run successfully. One thing you may note here, particularly those of you who may be more experienced with Python, is the way I'm importing these two modules. Using the syntax from pyqt4.qtcore import everything is often frowned upon. It's considered bad practice due to potential namespace conflicts. And I completely agree. You'll often see code that says something like this: from pyqt4 import qt GUI, and that's completely fine. However, you should know that all Qt classes begin with the letter Q, so namespace conflicts are not likely, and it will save us a lot of keystrokes in the future. Think about it this way: if you're a JavaScript developer, for example, imagine using jQuery and then you having another library that also uses the $sign as a global object. Now if you're getting the red squiggly lines here, indicating that PyCharm is not recognizing the PyQt modules, you might need to verify that PyQt is installed properly, for example by trying to import it in the interpreter. Additionally, you may need to wait a little bit before PyCharm indexes all the third-party modules you have installed on your computer. With this, as I mentioned earlier, we've imported all the necessary modules, so we need to start making those specific function calls. I'm going to make some spaces here because usually those function calls will come at the end of our file, at least our main file. And I'm going to create a new instance of the QApplication class. So I'm going to say app equals QApplication. And I'll explain line by line this later, just bear with me for now. Dialog equals QDialog. Dialog.show and app.execute. Okay, so this probably doesn't make a lot of sense to you right now, but like I said, I'm going to explain them. This is basically creating a new instance of the Q application. A Q application is a kind of a unique object. It's unique in literal sense, as in you should only have one Q application instance in your Qt application, even if your Qt application has multiple windows, etc. The dialog is assigned to a QDialog instance, and the QDialog is kind of a window. We'll look up more about that in our next video. I'm telling the dialog to show up on the screen, and finally I'm executing our application. Notice here that there's an underscore at the end because execute per se, just with this, is a reserved keyword in Python, so the developers had to go around a little bit and add an underscore. What happens if I run this application? Normally you would run the application by clicking the button right here, but for the first time you have to go to run and hit this run. It's going to ask you what interpreter you want. You say structure, usually the name of the file, and you can see our first application showing up on the screen. If I click the close button, you can see that the process has finished with exit code 0. Now, one thing I would like to mention before I go on is that often instead of this app.execute looking like this, you'll see something that looks like this: sys.exit app.execute in parentheses. What this means essentially, you'll get the same results, and if you don't believe me, I'll prove it. The only difference here is that with this line added, or with this call added, the application will exit with a specific exit code. This may be important to you, or probably is not, especially if you're a novice programmer, so you'll be just fine without this sys.exit call, and your application should look like this. You can see here that the Qt core is grayed out completely because we're not actually using it anywhere in our application right now. But I just wanted to show you the import statements because we will be definitely using it throughout our course. And that's it. That's all you have to do in order to initialize an actual PyQt application. What's this? 7 lines of code? Of course, the obvious question you're asking right now, well, Bo, that's all fine and dandy, but where's my application? Don't worry, we'll do that in our next video. Now that we've looked at the foundation of our application in the previous video, let's look at its building blocks as well. Let's familiarize ourselves with the QWidget class. QWidget is the base class for all user interface elements. All those UI elements inherit from the QWidget class, including the QDialog we saw in our previous video. All this talk about QWidgets and you're probably very confused already, so let's look at some examples. As you can see here, we have several UI elements on this screenshot. Right here we have the QGroupBox, which is this group box, the QDateEdit, which enables us to edit the date easily, QTimeEdit, QLineEdit is just a standard text box. One of the most used elements is also QLabel, which is just static text, and there's also the QTextEdit. Some other elements you will likely use is the QPush button, which is OK or cancel, a yes or no button, and all these inherit from QWidgets, or if you will, we call all these collectively QWidgets. Think UI element equals QWidget. Now this screenshot was taken straight from the Qt project documentation page, and it does not seem that their machine is running Windows or that this screenshot is very up to date. So don't worry, you will still have the native look and feel of whatever operating system you're working on. Two QWidgets that stand out from the crowd are QDialog and the QMainWindow widgets, or classes. We saw the QDialog in our previous video, so what exactly is the difference between the two? Well, let's take PyCharm for example. Imagine that this entire PyCharm window is one QMain window. We have all the usual stuff, the menu bar, the toolbar right here with some breadcrumbs in this case and some buttons. We have the main widget area, if you will, or the central area of our application where all the stuff is usually happening. And at the bottom here we have the status bar. Now let me go to File and hit the Settings. What pops up right here is also another very rich interface. As you can see, you have buttons, you have a list here, another list here, a search box, a combo box. There's also, of course, the QComboBox class. All in all, it's a very rich interface, but I would consider this a QDialog. Throughout this course, we'll primarily be using QDialog and not QMainWindow. Let me close this for a second. While this may seem somewhat limiting at first, in reality, it really is not. Think of QDialog as the QMainWindow's younger cousin, which provides most methods as its sibling, but not implementations for certain things such as the menu bar, the toolbar, or the status bar, or other things that I've mentioned. Since we understand the basics of the foundation and the building blocks of our application, let's make our first application in our next video. In my last video, I've mentioned that the Q widgets are essentially UI elements, or the elements that display on the screen, but you probably did not really like my demonstration of those UI elements, which consisted admittedly of an ancient screenshot and me moving my mouse cursor around PyCharm. Since I felt bad for doing that, I've created a small application to demonstrate some of the Q widgets available to you as a developer. I'm sure this entire application looks like a very familiar interface to you, at least if you're on Windows. But to start off, we have the Q menu bar at the top here. We have our standard file, edit, and help Q menus. And if I click file here, you see that I can specify a shortcut for new in this case. I can add icons as well as I did for new, open, and exit. I can even create a checkable menu. So if I go back here, you can see that Qt's awesome is unchecked. And since Qt is awesome, I'm going to check it back. If I hover over the edit Q menu, we have the preferences and a sub-menu appears. Going a little bit south, we have here what's called a Q toolbar, and what this essentially is a shortcut to some of the actions found in the Q menu bar. We have here new, open, and exit. Remember that here I have many more. I have new, open, save, Qt is awesome, exit, and in edit I have even more. These are kind of, the general shortcuts that you would find in other applications as well. Lower than that, we have a cool little guy called the Q tab widget, and that provides us with 2 tabs in this case. And in it we can put whatever we want. In this case I've put a demonstration of various Q widgets available to you, as I mentioned. So first off, we have here, this is actually what is bordering all these radio buttons inside is a Q group box. You can probably see the borders, and you've definitely seen it in other applications. As it is known, with radio buttons you can only select one of those, but that's not the case with the Q checkbox. As you can see here, we can select multiple checkboxes at once, and this together, this last Q checkbox here, has a tri-state property turned on. What this means that you can have this little square come in if there is a special selection you need to make. You can have it also be checked or be unchecked. Onto the Q label and Q line edit, arguably the 2 most common Qt widgets that you are going to use. This is a Q label essentially, it's just a static text. This is a Q line edit, something where you can type, so for example bow or Pluralsight. So normally when you're designing an application, you have a Q label that's going to describe to your user what your application is expecting you to put in, such as username in this case. But Qt also comes with a super cool property called a placeholder, and if you're an HTML developer, you may know this as a placeholder as well. So in effort to save some space, Qt developers came with this cool idea to have the kind of grayed out text or label put inside of the Q line edit itself. And if I just click it, that text is going to go away. Now what's interesting about this is that if you call a method to check what's the text contents of this Q line edit, it's going to return an empty string. So this your username right here doesn't count as text. Going even more down, we have our Q combo box. You've probably seen this as well. It just allows you to select different items. And right here we have another Q combo box. It's the same class with a different property. In particular, this one allows you to have editable items. For example, I can change this 6 to 0 and have it stay that way, when you click the submit button or do something else. Here we have the Q date edit, and with these up and down buttons we can change the date, or we can just type it as well, either way. right below it, we have another QDate edit with some different properties. You notice right off the bat that we have a different date format here. And if I click this down arrow right here, a nice calendar pops up that allows you to easily select the date. Another interesting Q widget I found is the Q font combo box. Clicking this arrow here allows me to see all the fonts I have installed on my system along with the preview of those fonts. Something that you might find useful when working with your application. Over to the right side, and before I actually move over, I would like to note that this is also a Q widget. It's called a Q vertical line. There's of course a horizontal line as well. This is a Q slider, and you may have seen this around, such as when adjusting the volume on your favorite media player. Of course, this is a Q horizontal slider, or a Q slider with a horizontal property. There is a vertical slider as well. Now these two guys are kind of unique to Qt from what I know at least. I've never seen them anywhere else in other UI toolkits. This is a Q dial which allows you to set some value from 0 to 100 for example. And this is a Q LCD number. Why does this exist exactly? I'm honestly not really sure. It's just there, I guess. It's an all class in its own. What you'll probably use much more often than QLCD number is this Q progress bar, and that's displaying, the loading state. You've seen that definitely around. Finally, we have here the Q spin box, which allows you to set some arbitrary numerical values. And we also have the Q double spin box. This is actually a separate class that allows you to put some floating point numbers or a double number. And at the end we have a button box and Q push buttons. This is actually of a class Q button box. Now seemingly these two are identical. We have the OK, cancel and apply button here and OK, cancel and apply buttons there too. So what's exactly the difference? Well, this button box is a class where you can select properties such as I want the OK, cancel, apply buttons to appear, but I also want abort, yes, no, etc. Those buttons will magically appear on the screen. But the more important property of a button box when it comes to comparing it to Q push button is that on Windows, this is the order of the buttons when, for example, a settings dialog pops up. You have OK on the left, cancel in the middle, and apply on the right. On different operating systems, the order is not always the same. Sometimes you may have cancel all the way on the left, OK all the way on the right, and to the left of OK would be an apply button. If you use button box, Qt will be able to figure out automatically what operating system you're running on and is going to adjust the positions of the buttons accordingly. This is definitely something to keep in mind if you're designing a cross-platform application. Now I'm going to another tab where I have more Q widgets as well. This is the Q plain text edit box. This is behaving like a notepad. There is no way for you to increase the font size as a user or make text bold. The Q text edit does allow rich text formatting, as you can see here. Change the size, italics, underline, and bold text. Now what's interesting about this one is that it takes any HTML or CSS. In fact, behind the scenes, this is actually HTML. On the left here we have the Q list widget with some list items, useful very much for selecting. Similarly to the Q list widget, we have the Q tree widget with some sub items here. And the Q table widget is right below. As you can see here, we have 3 rows and 3 columns. And what's interesting about this particular Q widget is that you can format the cells independently of each other. What I usually do is I put the last column as a status or something, and when there's an error, I color it red, done is green, and waiting is usually yellow. Finally, we have the Q web view, and this is actually loading a live website right now, and it looks like we have some sad news here. But just to show you that this is actually a live website, I'm going to click here, settings, go to, for example, register, and it seems to work just fine. Click go back to the home page and scroll down. It works perfectly fine. So there you have it. In our next videos we're going to start implementing some of these Q widgets, but my point of this video was to show you that Yes, Qt is very powerful and it can have all the UI elements that a normal Windows application does and some extra like QDial and QLCD number. As it always goes, let's build our first Hello World application, of course. Our application will have a label, or rather a QLabel, with the text Hello World, a text edit box, or as we call it, a QLine edit, and a button with the text close, of course that's a Q push button. These are arguably the three most common UI elements used and that you'll probably encounter throughout this course and when writing your application. This video will also allow me to show you the fact that the UI elements rendered on my operating system, Windows 8 in this case, look like, well, Windows UI elements. I will also introduce the concept of layouts, but only its basics. We'll look at the layouts in more detail later on. So let's start working. Remember that in our previous structure.py video, where I've introduced kind of the demonstration, we only had a large QDialog to pop up on the screen with the title of Python. There was nothing really on it. So let's add some stuff to it, the QWidgets that I mentioned earlier, and in order to do that we need to override some of the QDialog's methods. Since QDialog is class, we need to write our own class, and I'm going to name my class Hello World and going to inherit from QDialog. In this video I'm just going to override its constructor method. But the first thing you should do when we're overriding any constructor method when it comes to QWidgets is call its parent or QDialog's constructor method. The way to do that is simply by typing QDialog init and passing self as an argument. Now this falls under the basic structure of the code as well. Normally what would you have here, if you're overriding even a QMain window as well, you would put the QMain window here and the QMain window there. Essentially what I'm trying to say is that this is also the foundation, the same foundation we presented in the structure.py video, but a little bit extended since we need to override the init method, the constructor method. In some cases you may find a different way to override this constructor method by using the super keyword, and that will look something like this. Super, in this case we'll actually pass hello world as the first argument and call init. That's another way to do it. I prefer this first way. As you can see, it's much shorter, and I think this is also considered a newer way to override the constructor methods of a base class, which in our case is QDialog. Now let's add that layout that I've mentioned. So I'll just do QVBox layout. Layouts are essentially, well, what its name says. It's a layout on how your QWidgets should be displayed on the screen. There's a vertical box layout, there's a horizontal box layout, and there's also the grid layout as well. Think of this if there were only as a vertical box layout. For example, there's a horizontal line of elements here, then another one here, then a large one here, etc. A bunch of elements aligned vertically. Similarly, the horizontal box layout, the HBox layout, will be a bunch of elements aligned horizontally. And the grid layout will be, for example, you'd have an element in row 1, column 1, row 2, column 6, etc. Grid layout is most likely what you will use with the more complex application. Now we're going to add those QWidgets that I mentioned. So the first one is the label. And the QLabel class constructor takes its text as an argument. So I'm just going to type hello world here. The next one would be line edit. QLine edit constructor method also takes an argument with text, but we want our line edit to be blank. Finally, I'm going to add a button, which is the Q push button, and again you can add whatever text you want here, which in our case is going to be close. When clicking this button, the application should shut down. Now what I need to do is add these QWidgets to the layout. I'm going to say layout.addWidget label, and I'm going to copy paste the same code 2 more times, add the line edit as well, and finally the button. And the last thing I need to do is instruct the QDialog constructor method to use this layout to display the elements on the screen. So I'll just say self.setLayout, layout. Finally, one important thing to remember to do is rename this QDialog. We don't want our empty, blank, useless QDialog here. We want our new Hello World dialog to pop up. If I run this file, watch what happens. We have a newer, much smaller dialog, and you can see that the elements are arranged vertically. There's our label with the text of Hello World. There's our QLine edit, which we can type any text we want, also Hello World, for example, or Pluralsight. And there's our close button as well. However, our application doesn't really do anything right now. It just displays these kind of useless widgets. As you can see, if I click this close button, nothing happens. So let's add some interactivity to our application. Before we begin working on our interactive application, and just to be sure, by interactive I mean that there's an interaction between the user and the application, we need to understand one very important concept: events. When I say events, you may be thinking of something like concerts, or a picnic, or a parade, or something fun. Well, this is not exactly what I mean, but I promise I'll try to make events, when it comes to programming languages, at least half fun. Events are actually crucial to any interactive application, and most programming languages, such as Java, C# or JavaScript, incorporate them in some way. Without getting into the computer science textbook definition of what events are or not, I'm just going to say this: an event is when something happens. This actually sounds a lot like something taken from the dictionary. Well, that's what it is. But what exactly do I mean when I say something happened? I'm moving my mouse now. An event has occurred. I just clicked something maybe. An event happened. Did I type something on my keyboard? There's another event, or actually multiple events in a row. When it comes to wording, we usually say that an event is emitted, fired, or broadcast. You can take your pick. I normally say fired or emitted. Also, you will often hear me of referring to events as signals, and this is actually coming straight from the Qt syntax, as you'll see soon. Now, we actually need to capture those events and do something with them. In Qt, if an event is not caught or handled, as we actually say, it is being disregarded. This handler can be any Python callable, and by that I mean any Python function or method. You can think of a handler as an action you want to take when a particular event occurs. One note: a handler is sometimes called an event listener as well. Those two terms are equivalent. Here we have an example of an event that is not being handled and as such is being automatically disregarded by the garbage collection in Python and Qt. Right here we have an event that, when fired, prints the message "Hello" to the Python console. Finally, we can also attach events to our own methods, as I mentioned earlier, and do whatever we want to do. One good example would be asking the user if he or she wants to save the changes when exiting the application. Let's make a definition. A handler, which is a function, is attached to an event. So you've seen in our previous video that when I clicked the close button, nothing happened. Be aware that an event, specifically the clicked event, has been fired, but there was nothing to handle it, so it was automatically disregarded, as you can see in our first example here. But if you were paying really close attention in the last video, you also noticed that we didn't really specify any events anywhere in our code. Yet I'm saying that an event has been fired. Well, that's because Qt actually comes with some built-in events, such as clicked, text change, for example, which fires when you change the text in the QLine edit, and remember that's our text box. What's also interesting about this text change event is that it also passes a parameter to whatever handler is attached to it. There are many other events available overall. I'd say that every UI element has some sort of an event that it emits. One more important thing I feel I should say is that an event is sometimes referred to as a signal. and the handler is sometimes referred to as a slot. I know, so many different names, but the signal slot names actually come straight from the Qt syntax. Now you're probably confused more than ever, but trust me, even though events are a very powerful concept, they're actually really simple to understand. As I said earlier, it is our job to capture or handle those events and do something with them, and that's exactly what we're going to do in our next video. We have here our little Hello World application, which in the meantime I've renamed from structure.py to hello world.py. And just to remind you what it looks like, I'm going to run it. Recall that if I click this close button, nothing happens, at least nothing visible happens. As I mentioned in the previous video, an event has been fired, but there was nothing to handle it. Let's fix that. In order to attach an event to a handler, we need to connect the two, and for that we use the following syntax. I'm going to say button.clicked.connect self.close. Now let me explain this line a little bit. Button is our QPush button with the text of close that we have defined earlier, and the QPush button just happens to emit the clicked event, which, as you may imagine, happens when the user clicks that button. The connect is what actually attaches our event to a handler, connects the two. The handler in our case is this self.close call. The self.close is a built-in method in QDialog and some other Q widgets as well that is simply going to close the window. One important note, even though this self.close is a function, we're not passing it as such, we're just passing it as an argument. What this means, translated, is that you should not add parentheses at the end of the handler even when we write our own handlers, as you'll see later. Now what we need to do is, well, we don't really need to do anything anymore. In a true Pythonic way, this one line of code is what does it for us. So let's test it. If I hit the close button right now, the application closes, and as you can see here, the process has been finished. Now let's do something more exciting. Remember that we have our Hello World Q label and an empty Q line edit. Well, what if we wanted for the text that we type in Q line edit to immediately appear in our Q label as we type it? We're in luck. There is a very simple way to implement this too. So if I just do line edit dot text changed dot connect label dot set text, this is going to work. But before I test it, let me explain this a little bit. Line edit is our Q line edit. The text change in this case is the event that is emitted every time the text has been changed in our Q line edit. Connect is the same as above, and the label, being our Q label, has a set text method that's going to set the text of the label, as its name says. Now the set text does take one argument, which is the text of the label. So if I say label.setText hello world, it's going to set the text of the label to hello world. But notice here that we're not passing any arguments. Let's see what happens if I test this. And if I type here Pluralsight, you can see that the text in QLabel appears just as we type it right here. What happens behind the scenes is that every time a text has been changed in this QLine edit, an event has been emitted, and we have connected that event to our QLabel. Hello Bo. That works too. Anything will work. And of course our close button still works. But how exactly does the label know what text to update itself to? We're not passing any parameters. Well, I've already mentioned earlier that events can carry parameters or arguments with them. But to explain that a little bit better, let's refactor our code. Let's create our own method called changeTextLabel. This method is going to take text as an argument, and all we're going to do in this method is update our label. And to do that, I'm going to first need to make this label variable an instance variable so we can access it from other methods as well. And right here I'm going to call that same method setText and set it to this text from the parameter. This obviously needs to be changed to self.changeTextLabel. Notice here again that I'm not passing any arguments here. What happens if we test the application now? Hello, Pluralsight. You can see that we have the same results even with the code refactored. As you can see, the text change event actually sends a parameter to our handler, in this case the change text label. But how did I know this? Well, from the documentation. The Qt documentation specifies what event sends what parameters and what types of parameters as well, such as integer, string, boolean, etc. Now I also want to make you aware of an older syntax for attaching a handler to an event. You'll still find this syntax being used in some older PyQt or PySide applications. This older syntax looks something like this. Let's get rid of that real quick. So if we wanted to accomplish the same result as we have with our line edit here, the older syntax would look something like self.connect line edit signal text changed. We need to pass the Q string, which is kind of a drop-in replacement for the Python string, as an argument. And finally we need to pass our handler, which in our case is self.changeTextLabel. Yeah, you can probably see why there's a new style syntax here. You really should not be using this syntax in any of your code. This is just something to make you aware that there is this older syntax so that you're not confused if you happen to encounter it in some older code. Well, now that we know signals, or events, there's really just one more thing keeping us apart from creating our first real application, and that's layouts. You saw that I have been using them from the beginning. But why? Let's answer that question in our next video. I've touched briefly on the topic of layouts before, but never really explained what they did and why they're useful. Layouts, like events, are a simple yet powerful concept whose primary focus is not just on the UI design, but the user experience as well. Many programming languages incorporate layouts in one way or the other, and for example, if you're an Android developer, you'll definitely know what I'm talking about. But let me demonstrate some layouts that Qt ships with. First off, we have the vertical layout, or the vertical box layout. This layout has its Q widgets, remember those are the UI elements, aligned in a vertical order. We can see here that our elements are aligned one below the other. Recall also that our Hello World application has this kind of a layout set. Contrary to the vertical layout, we also have the horizontal layout, or the horizontal box layout. In this mockup, you can see that the elements are aligned next to each other in a horizontal fashion. We also have the grid layout, which, as you probably assume, aligns its elements in a grid, or a table of rows and columns. So we see here that we have our two elements, the QLabel and QLineEdit, on the first row, but our QPush button is on the second row. Similarly, notice that our QLabel is in the first column, but the QLineEdit and QPush button are in the second column. With grid layout, you can have as many rows and columns as you'd like. And also, the grid layout is likely the one you will use the most when writing somewhat complex applications. I should also mention that there is another one, the QForm layout, and although it is very similar to the grid layout in its behavior, the form layout can contain two columns, and only two columns. Normally, you would use the form layout, well, when you want your user to fill out some sort of a form. So those are the four basic layouts that the Qt ships with. But I still haven't said anything about their usefulness so far, and it may seem odd to you that we have to write many extra lines of code just so that we can add the Q widgets to our application on the screen. Well, I didn't talk about that because the best way to demonstrate their usefulness would be when I'm demonstrating the layouts themselves, which is what I'm going to do in our next video. In the last video I showed you what layouts are, but just as some mock-ups and images on the screen. So in this video we're going to see them in action. I have here our Hello World application from before, which as you might remember uses the vertical box layout. But just to remind ourselves, let's run the application. And you can see that the elements are aligned in a vertical order. We have our Q label at the top, our Q line edit in the middle, and finally our Q push button at the bottom. Now if I were to only change this letter V to a letter H, I would make this a horizontal box layout. Let's run the application. We still have the same elements as you might suspect, but this time they're aligned horizontally. We have our Q label on the left, our Q line edit in the middle, and our Q push button on the right. Similarly, we can make a Q grid layout as well. But this is going to require some setting up. We're namely going to instruct our layout what elements we want to display in what row and column. Or in other words, to simplify, we want to tell the grid layout where we want our elements positioned within that grid. Now, the rows and columns in the grid layout are zero based, so if I wanted our label here to be in the first row and the first column, I would say comma 0, comma 0. This second parameter, but the first 0, denotes the row, and this third parameter, but the second 0, denotes the column. I want our line edit to be next to the Q label, meaning in the same row, but in the second column. So I'll just add 0 for the row number 1, and I'll add 1 here for the column number 2. As you may imagine, this works kind of like the same as a list in Python. The 0 index is the first element in the list. Finally, I want our Q push button to be to the bottom right of the screen. That means we want it to be in the second column and the second row as well. So I'll just say comma 1, comma 1. Let's run the application, and voila, it's grid aligned. We have our Q label to the left in our first row and first column. We have our Q line edit in the first row but the second column. And finally our Q push button in the second row and in the second column as well. I also promised you in the last video that I'll demonstrate the usefulness of the layouts as well. Looking at the code here, you're probably wondering why our layouts are cluttering it. I mean, for every widget that we want to display on the screen, we have to call this add widget on our layout. This seems very silly and redundant and definitely not Pythonic. Well, there are some tools that will help us automatically manage our layouts so that we don't have to care about them almost at all, but that's slightly more advanced and they'll be in the part 2 of this course. For now, I'm just going to demonstrate the usefulness of the layouts. I have here the application that looks the same as our Hello World application, but don't be deceived. Behind the scenes, there's a slightly different code. The difference being that in this application on the screen, I have no layouts defined. And as you can see here, I have exited from our Hello World application. Now watch what happens when I resize this application. Remember, this one does not have any layouts defined. If I increase its size, or modify it, or do anything with it, you can see that the resize has no effect on the UI elements whatsoever. In fact, let me make this smaller, and you can see that the UI elements are clipped. This is definitely not something you want your user to experience as well. Now I'm going to close this application and run our application with the QGrid layout, and watch what happens when I resize this one. You can see that the elements are kind of reflowing and realigning themselves. In other words, they're obeying the resize events that fires when we resize our window. Now if I want to make this one smaller than the elements themselves, watch what happens. I can't make it any smaller than the QGrid layout tells me to. Qt is smart enough to figure out, okay, this is really the smallest you want to go. So this may seem like an insignificant problem, but it's not. Trust me. You're listening to someone who has made the same mistake before. I completely thought of layouts as irrelevant. Long story short, I spent days refactoring the code so that I can add layouts to it. Moral of the story is, use layouts. They're your friends. Well, the moment is here. Now there's nothing stopping us from creating our first real application, and this is what we're going to do in our next module. Let's recap what we've learned in this module. First, we looked at the basic structure of the code that must be present in every Qt application in order for it to run. We then defined what QWidgets are, and remember, they're the UI elements on the screen, and I also showed you some of the QWidgets that exist in Qt. We also saw what events or signals are and how they are related to their close cousins, the handlers or the slots. Remember, the event is fired, or synonymously, a signal is emitted, and then it's handled by the handler, or the slot. Lots of naming there, so hopefully this makes sense. An event is the same as a signal, which fires or emits, and a handler is the same as a slot. These names are just synonymous. We saw the first-hand communication between the two when we close our application by clicking our Close Q push button, or how our QLabel changes its text when we edit the text in our QLine edit. Finally, we've seen how simple yet powerful layouts are and how they can help us build user-friendly applications. Coming up in our next module is designing a real application from scratch, using the knowledge we gained so far, but also learning new things along the way.